Hello students, myself Ashish Chawla, and today we discuss the topic circle. First of all, we define the circle. How we can define a circle? Suppose there is a fixed point. Now from this fixed point at a constant distance, I have to collect all the points which are at a constant distance from this fixed point. I have to collect all the points which are at a constant distance from the fixed point. So collection of all such points form the shape of a circle. This is your fixed point, and from this fixed point you have to collect all the points which are at a constant distance from the fixed point. The collection of all these points form the shape of a circle. When we connect all these points, this will form a shape of a circle. So in this fixed point is called the center of the circle, and the fixed distance from this fixed point is called the radius of the circle. Now generally the center of the circle is represented by O and the radius of the circle is represented by R. So in generally we represent every circle. Let's say there is a circle C having a center O, radius. It means there is a circle C with center O and radius R. Now we define the various terms related to circle. The terms which are related to. Now first of all we define arc. What do you mean by arc? Let's say we have a circle here, and this is the center of the circle. Let's say there are 2 points, point A and there is a point B. Now when we take any point on the circumference of the circle, now this portion AB, this portion, or you can say a part of a circle, is called the arc. This arc AB, and there is another way. This is also an arc AB. So but its length is less than the semicircle, because the length of this arc is less than the semicircle, so it is called minor arc, and the length of this arc is greater than the length of the semicircle, so it is called major, and the arc is represented by AB, and there is a curve over it, arc AB. So in this way we can define the arc. Now after arc we define the chord. What do you mean by the chord of a circle? Let's say we consider again a circle, and there is a center O, and we take any 2 points on the circumference of the circle, that is A and B. Now when we connect these 2 points by a straight line, this straight line is called the chord of a circle. AB is a chord. When we connect any 2 points on the circumference of the circle by a straight line, then it is called the chord of a circle, chord AB. Now this chord will divide the circle into 2 parts. The region between the chord and the minor arc, this region, is called the minor segment. Minor segment. The region between the chord and the minor arc is called the minor segment, and the region between the chord and the major arc is called the major. Now when the chord passes through the center of the circle, this chord is passing through the center of the circle, O. So this chord is called the diameter of the circle. When chord is passed through the center of the circle, it's called diameter. And we know that the distance between any point on the circumference of the circle to the fixed point, that is center, is known as radius. This is radius OA, and OB is also radius. From this we can say that diameter is twice of radius. Diameter is twice of radius. And one more important thing that is noticed here, the diameter is the longest chord of a circle. Diameter is the longest chord of a circle. When the chord is passed through the center of the circle, then it will divide the circle into two equal regions known as semicircles. Semicircle. In this time there is no minor segment, no major segments when the chord is passes through the center. Simply when the chord is passes through the center, then it will divide the circle into two equal halves. And these two equal halves are called semicircle. This is a semicircle and this is also a semicircle. Now after that we define. Now we have a circle, there is a center and there is any 2 points on the circumference of the circle A and B, and there is a center O. When we connect these 2 points to the center, of the circle, then it will form a shape of a sector. The region between the two radii and the minor arc is called the minor sector. This region is called the minor sector. And the region between the major arc and the two radii is called the major sector. And the angle which is formed by the minor arc at the center, this angle is called the central angle. The angle made by arc at the center of the circle is called the central angle. More clearly, let's see here. These are the 2 points A and B, and this is our center O. Now the angle made by these arc at the center, that is theta, let's say this is your central angle. Now we can find the area of sector. Area of sector is equals to central angle, that is theta, upon 360 into pi r square. So by this formula we can find the area of sector, that is theta upon 360 into pi r square. Now we can find also the length of arc AB. Length of arc AB. Length of arc AB is defined as theta upon 360 into 2 pi r. This is the formula by which we can find the length of the. Now after that we come to the concentric circle. What do you mean by concentric circles? Concentric circle means the circles which are having same center but different radii are called concentric circles. Let's see here. Here we have 3 circles. All the 3 circles are having the same centers but having different radii. Let's say this is having radii R1, this is having radii R2, this is having radii R3, R1, R2. So all these 3 circles having the same center but they are having different radii, so they are called the concentric circles. Now after that we define the terms secant and tangent. What do you mean by secant or a tangent? Let's consider a circle with center O. Now when a line which just passes through the circle at one point, this is the point of contact. Now this line passes through the circle at just one point. This is called the point of contact. So this line is called the tangent to the circle. This line is called the tangent of the circle. Now when a line passes the circle or intersects the circle at 2 points, so this line intersects the circle at the 2 points, so this line is called the secant. When the line is just passes through the circle at one point, is called the tangent to the circle, and when the line is passes through the circle at 2 points, the line is said to be secant. And the one more important thing about tangent is that this is our tangent. Now this is radius, the center of the circle O, and this is the point of contact. Now when we connect this point of contact to the radius center, so this line is always perpendicular to the tangent, or we can say the angle between the radius and the tangent at the point of contact is always be 90 degree. The distance, the angle between the tangent and the radius at the point of contact is always be 90 degree. So based on this we can do one problem. Let's see here. So if I have a circle in center O, and there is a point P outside the circle, and there is a tangent PT, let's say PT is a tangent, and this circle having a radius 5 units, and the circle is at, and the length of, let's say the point P is at a distance of 12 units. So we have to find the length of tangent, that is PT. We have to find the length of tangent PT. So don't do hurry. First of all, judge where the right angle is made. We know that the tangent and the radius are making a 90 degree angle at the point of contact. So this is our point of contact. So 90 degree is made here. So let the length of PT is x. So in triangle PTO, so according to this, because the 90 degree is made at the point T, so the side opposite to 90 degrees called hypotenuse. So in this case the 12 is the hypotenuse. So we can say 12 square is equals to 5 square plus x square. So 12 square is 144, the 5 square is 25 plus x square. When we shift 25 to that side, so 144 minus 25 equals to x square. So 144 minus 25 we get 119 is equals to x square. So x is equals to under root of 119. The length of PT or the tangent should be 119. It is always remember that where the right angle is, where the 90 degree is made. The 90 degree is made always at the point of contact, that is where the tangent and the radius are meeting. One more important fact regarding tangent. So let's say there is a circle with center O, and there is a point P outside the circle. Now from this point I can draw two tangents, PT, and there is another tangent PT. Now connect T and O. The one more important property about tangent is if we draw the tangent from the external point to the circle, the length of these two tangents are equal. PT and PT dash are equal. Let's see how. Now when we connect, let's say connect PO, and we know that the tangent and the radius are perpendicular at the point of contact. So this should be 90 degree, and here same case this should be 90 degree. Now in this triangle PTO and PT-O, in triangle PTO and PT-O, what is common? That is OP, the line OP is common, and OT and OT dash is also equal because they are the radius and their angle is 90 degree. So OP equals to OP common, and OT is equals to OT dash because they are radius, and their angle T is equals to angle T dash. Both are 90 degree. So by RHS criteria we can say that triangle PTO is congruent to triangle PT-O, and by CPCT we can say that PT equals to PT dash. PT equals to PT dash. So this is our result. So when we draw tangent from the external point of a circle, from external point of the circle to the circle are equal in length, that is PT equals to PT dash. And one more important point is that their angle O or C, angle POT is equals to angle POT dash. Again by CPCT we can say that that is this angle POT and POT dash. These two angles are equal. So we can say that the tangents are make equal angle at the center. PT, the angle made by the tangent at the center are equal also. And the one more thing is that angle OPT is equals to angle OPT dash. That is angle OPT means this angle, or OPT dash means this angle. These two angles are also equal by CPCT agreement. So we can say that the line joining the external point to the center of the circle bisect the angle, bisect this angle. Okay. So these two angles are equal.